Welcome to SS1 Music. This lesson covers recording techniques with a focus on microphone placement, one of the most important practical skills in music production and audio engineering. The quality of a recording depends enormously on how and where the microphone is placed relative to the sound source. Understanding microphone placement principles helps you make better recordings with any equipment. A microphone is a transducer, a device that converts one form of energy to another. Specifically, a microphone converts acoustic energy, the vibrations in air that we perceive as sound, into electrical energy, an electrical signal that can be recorded, amplified, and processed. This electrical signal is then sent to a recording device, amplifier, or PA system. Understanding the basic physics of how a microphone works helps you use it effectively. Sound is air pressure variations radiating outward from a sound source. When these pressure variations reach the thin membrane inside the microphone, called the diaphragm, they cause it to vibrate. This vibration is converted to an electrical signal by a transduction element whose specific design determines the microphone type. The two most common microphone types for recording are the dynamic microphone and the condenser microphone. A dynamic microphone uses electromagnetic induction to generate the electrical signal. It is robust, can handle high sound pressure levels, requires no power, and is well suited to live performance, drums, and loud instruments. The Shure SM58 and SM57 are the most widely used dynamic microphones in the world. A condenser microphone uses changes in electrical capacitance to generate the signal. It requires phantom power, typically 48 volts supplied by the mixing desk or audio interface. Condenser microphones have a more detailed, sensitive response and are generally preferred for studio recording of vocals, acoustic instruments, and nuanced sources. The Neumann U87 is considered the reference condenser vocal microphone, though they are excellent affordable options at a fraction of the price. The polar pattern of a microphone describes the sensitivity of the microphone to sound arriving from different directions. This is represented as a diagram showing a circle or other shape around the microphone. Cardioid, the most common polar pattern, is sensitive to sound from the front and sides but rejects sound from the rear. The name cardioid comes from the heart-shaped diagram. Most vocal and instrument microphones use a cardioid pattern. Omnidirectional, sensitive equally to sound from all directions. Used when you want to capture the full ambience of a space. Bidirection or figure of 8, sensitive to sound from front and rear, but rejects sound from the sides. Used in certain stereo recording techniques and for interviewing in broadcasting. Hypercardioid, more directional than cardioid, tighter front pickup, some rear pickup. Used where maximum isolation from surrounding sound is needed. Knowledge of polar patterns is essential for correct microphone placement. If you are recording a singer with a cardioid microphone and there is a loud noise from the side, the microphone will partially pick it up. If you use a bidirectional microphone to record two people facing each other in an interview, both voices are picked up naturally without either speaking into the back of the microphone. Microphone placement is both a technical and artistic decision. The distance between the microphone and the sound source dramatically affects the recorded sound. Close miking, placing the microphone within 30 centimeters of the source, captures a dry, direct, detailed sound with minimal room ambience. This is the standard approach for studio vocal recording, close miking guitar amplifiers, and recording individual drum components. Proximity effect, a phenomenon of directional microphones including cardioid, causes a boost in bass frequencies when the microphone is placed very close to the source. Experienced vocalists use this deliberately to add warmth to their voice. Be aware that less experienced vocalists can accidentally create a booming, unbalanced bass sound through excessive proximity. Room miking, placing microphones at a distance from the source, from 1 to several meters, captures more of the acoustic space of the room. This adds ambience and a sense of space to the recording. The character of the room is as important as the instrument when using distant miking. Overhead miking is used for drum kit recording, placing 2 or more microphones above the kit to capture the overall sound and the cymbals. Stereo recording techniques using 2 microphones create a stereo image. The XY technique places two cardioid microphones at 90 degrees to each other with their capsules as close as possible. The AB technique places two omnidirectional microphones spaced apart to capture a wide stereo image. For Nigerian musicians recording vocals in a home studio, a cardioid condenser microphone placed 15 to 30 centimeters from the mouth, slightly above and angled down toward the lips, is the standard starting position. A pop filter, a wire ring with a fine mesh, placed between the lips and the microphone prevents the explosive airburst from P and B sounds, called plosives, from causing an unpleasant thump in the recording. Many Nigerian musicians record in home studios or in studios without professional acoustic treatment. Room acoustics, the way sound behaves in a recording space, significantly affect the quality of recordings. Hard, parallel walls create strong reflections and resonances that color the recording. A bedroom with soft furnishings, curtains, carpet, and clothing in wardrobes provides natural acoustic damping. Recording vocals in a wardrobe filled with clothes is a real technique used by many home studio producers to achieve a drier, less reverberant vocal sound. Affordable acoustic treatment options include acoustic foam panels on walls, a vocal booth made from moving blankets, and positioning the microphone to face away from reflective surfaces. Electrical noise, from fans, air conditioning, traffic, generators, is a significant problem in Nigerian home studio recording. Scheduling recording sessions when the generator is off, using quiet microphone preamps, and using directional microphones facing away from noise sources or help. Today we covered that a microphone converts acoustic energy to electrical energy. Two main types: dynamic microphones, robust, no power needed, handle high levels, and condenser microphones, more sensitive and detailed, require phantom power. Polar patterns describe directional sensitivity, cardioid most common, omnidirectional captures all directions, bidirection captures front and rear. Close miking gives dry direct sound, room miking adds space and ambience. Proximity effect boosts bass with close mic directional microphones. Standard vocal position, cardioid condenser 15 to 30 centimeters from mouth with pop filter. Room acoustics and noise management are critical challenges in Nigerian home studio recording. For your exercise, draw the cardioid, omnidirectional, and bidirection polar pattern diagrams in your exercise book and write one sentence describing when each would be chosen.